All right. So we did 21 last night for homework. Now the trick to that one was you had to fill in some zeros, right? Did everybody figure that out? You had to fill in quite a few zeros. Did you fill them in on the outside too? Good. Okay, you should have. So let's take a look. Let's do number 21 real quick. Okay, so on the outside, I should have x squared plus 0x minus 1. And then what do I have on the inside, Mitch?
2x to the 4th plus 0x to the 3rd plus 0x squared
Plus 7. Did the wrong number 21 or what? Yeah. 21? Isn't that what we did, 21?
Yeah. Oh, we did 28.
Anyways, first thing we need to do, we need to ask ourselves what? What times x squared is 2x to the 4th? And that is 2x squared. So we put it above the x squareds. And then we multiply. 2x squared times x squared is 2x to the 4th. 2x squared times 0x is right? Okay. And then 2x squared times negative 1 is negative 2x squared. And then you subtract. Make sure you're subtracting. I came across some people that weren't actually subtracting. You got to subtract. 0 minus 0. 0 minus a negative 2. Positive 2x squared. Okay. So, what times x squared is 2x squared? 2. So, do I have any x's? No, I just have a plus 2. You got to make sure you put that in the right place. So, 2 times x squared is 2x squared. 2 times 0x is 0x. 2 times negative 1 is, and we subtract. Those cancel. 0 minus 0, 0. 7 minus a negative 2. Positive 9. And that's my what? Remainder. So my final answer should be 2x squared plus 2 plus 9 over x squared minus 1. Good. Okay. And that would be the long division way of doing that. No. You don't have to have the 0x on the outside. That's a good question. I like to put it there because it makes everything line up. I'm one of those people that likes to have, I don't like blank spots. But yeah, if you didn't, you wouldn't have this. And you wouldn't have this. But you would just have to make sure when you fill the rest in that it goes in the proper place. Yeah, but no, you don't have to. Do we need to do another one of these to make sure we have this down? One more? Okay. So let's go ahead. I have one in my book here that you guys don't have. Hopefully a little bit more challenging than that one. You like to challenge yourself, though. Okay, I am dividing x squared minus x plus 1 into x squared, x to the 4th plus 2x squared. Okay, but I need to fill in what? My x to the 3rd. Okay, and then minus x plus 5. This one isn't going to be too terribly challenging. Hey, Devin, where do I start here? Okay, because x squared times x squared gives me x to the fourth, right? Yep. Okay, and then x squared times x squared, x to the fourth, x squared times negative x. Negative x cubed, right? X squared times 1, x squared. And then I do what, Logan? Have you caught on to this yet? Subtract. It's just regular long division is what we're doing. Okay? So the x to the fourths cancel. And then 0 minus a negative 1. Anybody? When I'm subtracting a negative 1. Plus 1. So I get positive x cubed. And then I have 2 minus 1. Plus x squared. Okay. Now what, Kate? I just subtracted. Because I want to know what times x squared gives me x cubed, right? And Kate says it's an x. And I agree with her. So then x times x squared is x cubed. X times negative x is negative what? Negative x squared. And then x times 1 is positive x. So we got a lot of just regular x's here. Okay. X cubes cancel. I have positive 1 minus a negative 1. Positive 2x squared. And then I have a negative 1 minus 1. Negative 1 minus 1. Negative 2x. Now what, Carissa? So you want to ask yourself, what times x squared is 2x squared? What times x squared is 2x squared, too? So now I have 2 times x squared, which is 2x squared. I have 2 times negative x, which is negative 2x. And I have 2 times 1, which is 2. And then I do what here? Subtract, right? Subtract. I subtract now. I'm doing long division. These cancel. Negative 2 minus a negative 2. 0. Those cancel too. Positive 5, because that comes down, right? Positive 5 minus 2. Positive 3. Okay, so up there I have x squared plus x plus 2. Plus my remainder, Lorelei, is what? Over what? 3 over x squared minus x plus 1, which is just the front part, right? Okay, so you take your remainder and you put it over what you're dividing by. Okay. Now that's one option for division. I will tell you, that's the only option you're going to want to use when you have a quadratic, when you're dividing by a quadratic. Okay. Now, when you are dividing by a binomial, binomial means what? 2. Okay. So let's say we're dividing x cubed plus 2x squared minus 6x minus 9 by x minus 2. A decent amount. It's synthetic division. It'll be the same amount of spaces as a synthetic substitution problem. Okay. If you have something like this, you could do long division if you wanted to. It'll still work. Okay. But it's going to be probably quicker to do synthetic division. Okay, you guys remember how to synthetically substitute? You know how to set it up at least, right? Okay, it's like your upside down division sign. Now, you got to be careful here. You got to take what x equals. So we're still doing substitution. But what does x equal out of this? Positive 2, right? Okay, so when I plug this in, on the outside, I need a positive 2, not a negative 2. Okay, so be careful with that. First number I need is? It's what's in front of it. 1, 2, negative 6, negative 9. Now, if I was missing anything, I'd fill it in with a 0, right? Okay, but I'm not. Okay. Anybody remember my first step when I do this, Jedediah? First, I got to bring down my 1. I guess you could do 1 plus 0. Okay, but I need to bring down my 1, and I need to get 1. And then what? Then I multiply. 2 times 1 is 2. And then add, and I get 4. 2 times 4 is, and then I add, and I get 2. 2 times 2 is 4. I add, I get negative 5. Now, this is where it's different from synthetic substitution. Your answer is not negative 5. Okay? This is actually your remainder. The rest of this is your answer. Okay? So, if you can do it forwards, that's fine. I like to do it backwards. So I know this is a positive 2. I know that this is a positive 4x. And this is a positive x squared, because there's just one of them. Okay, so I have x squared plus 4x plus 2 minus, or you can do plus, a negative 5 over, what did I actually divide by? X minus 2. Good. Okay, that's a lot faster than long division, but the problem is it only works when you have a binomial like this. Okay, so if you had x squared minus 2, you can't do that. It only works if it's x minus something or x plus something. Okay. You ready for another one of those real quick? Yeah, Derek, go ahead. I'm not. Well, it's plus, because we don't know what x equals. You know what I mean? Maybe x is negative 7, which puts the bottom at negative 9, which makes that a positive. We don't know what x actually equals here. Does that make more sense? So here it's okay to have a negative remainder. I get what you're saying. Yeah. It just has to do with we don't know what x equals. Obviously, x must be at least negative 3. Devin? Okay, x must be at least negative 3 to cancel out. Good question. Okay, so let's use this same one. Never fails, does it? Never fails. Okay, let's divide that by x plus 3. Okay, so when we set up our synthetic division now. So this is what out in front now? -3. Because this is a positive 3, so that means x would actually equal -3 to get 0. And then I fill in again, so I have 1, 2, -6, -9. Okay. Jack, what was my first step? Good. Bring down the 1. -3. And then I add -1. And then I multiply. And then I add. And then I multiply. And then I add. So now there's no remainder. So now I just got to fill this back in. This is my x squared minus x minus 3. And then there's no remainder in this one. Good back there? Okay. That's the main reason we did synthetic substitution earlier, is so we were able to do this later. Let's see here. I'm not going to show you how to do that. We should be able to do that. We'll just factor. Okay, let's start there. We might do a little bit more of this stuff tomorrow. We'll see. Tomorrow's Thursday, right? Okay. So now let's actually do some of these problems. So on page 356, we want to do 16 through 38 evens. That's more like 12 problems, but you're close.